Hi, everybody. My name is Ryan Duffy. I am the head of business development at Array Labs, which is an early stage company based out of Palo Alto, working on building the first satellite system designed from the ground up to capture high resolution 3D data. I do actually, because I'm on the road a lot, I actually live in Texas, and I am very sorry for bringing the 100-degree weather with me. So we had a range of different cover slides that we could choose from. So I opted to build this out starting the farthest from Earth, going a little bit closer, and then bringing it down to the actual Earth. I think that's a decent metaphor for what the marketing and sales function and product teams at Array Labs are doing. I think it's easy for us, especially as a company that is especially I'm following in big footsteps and standing on the shoulders of giants here, but compared to a Maxar or other folks in the industry, we are in our relative infancy. And so as a kind of high-tech, exciting startup, we can get caught in talking excessively about the technology, but not about the problems that we're solving, or pain points we're addressing, or solutions we're delivering to customers. So my presentation is designed to focus on what happens after the data hits the ground, hits the cloud, hits our servers. That said, I will try to deliver a quick. I'll try to quickly speed run through Array, our backstory. We founded in 2022, launched our first 2 satellites a couple years ago. We're now at over 30 employees, which is crazy. I think we've just about doubled already this year. As I said, we're building the first remote sensing system designed to capture high-quality 3D data from space. There's another section there talking about our approach, but I can get into that. Feel like this is relatively self-explanatory or obvious to everyone in the room, so we don't need to dwell on it. I mentioned that I don't want to spend too much time on the actual space system architecture side of things, but I'll just quickly run through that. Effectively, I think the key concepts to grok with our system and what we're doing differently. We are a synthetic aperture radar system, which effectively means taking multiple measurements over a flight path to effectively simulate a much larger aperture. We are not a single system, but a distributed system. So every imaging unit for us consists of 4, 16, or additional future increments of systems that work cooperatively to image the same place at the same time from multiple angles, allowing us to form a really high-quality 3D image. So I don't know why I started with the more technical slide. This effectively brings it home. Multiple satellites image the same place, same time, allowing us to form a high-resolution 3D image. So this gives a look at where we are at in our journey. As I mentioned, we launched our first 2 satellites on a SpaceX rideshare mission a couple years ago. Our next big milestone as far as space hardware goes is coming up, where we will launch the first production system. So the 2 satellites that we launched earlier were kind of engineering demonstrations, don't have an actual imaging instrument or payload on board. SIL, as the mission is called, will basically be the same satellite that we're launching in our first generation of production clusters. I think that, if anything, the visual from here gives you sort of a sense of how we envision scaling. This is a marketing slide, as you can probably tell, but there are significant benefits on the resolution, coverage, and revisit that we can attain with this architecture. Typically in Earth observation, you've had to, if you want to dial the knob up on one, you've had to make sort of trade-offs or compromises on one of the other sort of legs of that three-legged stool. I think this gets to sort of the crux of what we need to do as a company if we are to succeed in what we've set out to do. So we are a vertically integrated technology company, and that includes software and product and building the 3D reconstruction and image formation algorithms in the pipeline to process, serve, visualize, analyze all of that. We need to sort of own that in-house to control our destiny as a company. That's what we believe. A couple words on products. So because of some of the unique advantages of our system, we can serve two sort of quite distinct product lines. And I think the easiest way to think about this is who is controlling the sensor. So Site3D is an on-demand, higher resolution collection model where customers, it's basically a responsive tasking product. World3D is us controlling the sensor, utilizing spare cycles on the cluster to collect larger areas, including the entire landmass of the Earth. To start, we will offer that for all of Earth's landmass once a year. For some key geographies, which you can kind of see highlighted, we'll offer more frequent updates. That will be a DEM product to start. I don't know that anyone, there aren't many organizations that want a full 3D point cloud of the world. This gets into some of the advantages that I alluded to earlier. Because when you think about it, what our imaging clusters effectively are is this massive distributed aperture. So we're able to realize significant benefits in the collection capacity of the system. This summarizes the difference between Site3D and World3D. The focus of today's talk is Site3D. So I'm going to kind of unpack the backstory of Site3D a bit. We are pre sort of product company if you consider us, if you consider our main product to be the data that we sort of serve, the data and analytics that we collect and serve from our space systems. But constraint breeds creativity, and from a very sort of incipient early part of the company, I'm part of the founding team, I'm not an engineer myself, we've invested in at least a small sort of business function to engage customers and partners much earlier on in the journey to inform our product development and pretty significant strategic questions for the company. So as I mentioned, constraint breeds creativity. In a lot of early conversations that we had with folks, we would inevitably sort of hit a wall when the prospect or the person at the other end of the table would say, "This all sounds great, but this is there's not really a good comparable or precedent for me to sort of look at to understand how this would perform, what this would look like. Do you have any sort of proxy data set that we can look at to and poke around, plug into our own workflows and systems so that we can get a better sense of what to expect when the full system is flying?" And this prompted a few months of soul searching and pretty sort of intense debates within the company as to how we might go about serving that. We talked about downsampling aerial LiDAR, but that's not really a perfect comparison. And we ultimately landed on what I think, admittedly I'm biased, but what I think is a pretty clever solution that allows us to field a sort of prototype proxy data set that is not apples to apples with what our data will look like, but I think is, it's a good directional approximate or precursor. And that led us to, in earnest last year, begin collecting a significant amount of SAR imagery from a partner constellation, the Umbra constellation. So Umbra, for the uninitiated, is a commercial synthetic aperture radar provider. We've actually since expanded into optical as well, since we know that a lot of our customers will want an optical data set to overlay, fuse, stack with the 3D and surface models that we provide. Site3D today is a experimental commercial product. When I talk to someone and we get to the point where they're waving their credit card, there's a lot of caveats. There's a lot of performance and quality data that we can't confidently provide. So it very much is still a sort of experimental, early nascent product. That being said, the two sort of critical inputs for us are realizing and simulating the same sort of optimal collection geometry that we can get with our satellites, as well as the algorithmic techniques. So you can imagine why this is a win-win for us in terms of being able to start getting some data primitives out there, but also for our formidable software team to start, not to start, but to continue pushing on the key foundational algorithmic and software capabilities that we'll need to process data at scale from our system, where we're talking about, terabytes upon terabytes of data being thrown down from our space systems. So this is a dated snapshot. I don't really, that's intentional, since I don't really want to indicate where all we've been collecting data as part of the Site3D program. But it's 6 continents, it's terabytes of data at this point of raw imagery that we've collected and processed into 3D. This gives sort of an early look at how we wanted the workflow to develop. It tracks with it's the same story as what we'll do with our own space systems. Customers can get files and formats as they like it in their environment. We're highly flexible. But I think that this is the user story most pertinent today. 9 months ago, a year ago, we were really struggling. The product team that we built is a powerhouse, but they were not there a year ago. And so we were relying on kind of COTS tools and specifically desktop software that cost thousands and thousands of dollars for a single license, was not performant, and didn't allow us to socialize, the data or share it with anyone unless I had a Zoom screen share pulled up or they were sitting right across from me at the table. This led to a very early, very early exploratory work on my side with Cesium, but like I said, I am not the technical member of our product team. So that when the cavalry came in, we started to take a much more serious look at it. So yeah, this sort of reiterates the problem statement, and is what led us to build on Cesium. So I'm gonna go quickly through. I don't want to do a live demo, since it's the latency or performance issues that we would potentially get with our beta data explorer that's built on Cesium Ion. Those limitations would not necessarily be anything related to the technology, but potentially the hotel Wi-Fi. So I've just taken a few kind of snapshots and then I have a video that will show, give you a better sense of what this Data Explorer does. But these are the benefits. This is used extensively within the company at this point. It's not an external capability and won't be for quite some time. But I've tried to sort of chronologically tell the story here of how we rolled out and deployed capabilities and continue to release features for this internal tool. This is one of the first 3D collections that we made with Site3D. So this, what you're looking at was captured from space. I know exactly when it was because I should have circled it, but this is a stadium. So this was captured during the Summer Olympics last year in Paris. The resolution, and there are artifacts that you won't notice here that you will notice soon. But the quality, as I've mentioned, the quality is of this product's a function of two pretty key inputs, which we've been able to significantly enhance over the intervening months since this was taken now. So Site3D continues to get better. I think, so this just shows, this is just the base sort of surface. This is with 3D. This has been really helpful for us to actually sort of get into the weeds and compare, or at least, well, for me, eyeball compare. For our engineers, use a little bit more, use slightly more rigorous methods to compare sort of how our data aligns or doesn't with the Google Cesium sort of reference 3D layer, as well as track changes. So that's another unique capability. If I was doing a live demo, I would pull up a different urban scene that we have that shows what are cranes in the Google Earth system and our completely full developed buildings in our more recent capture. So you can start to see some of the artifacts. As I said earlier, it bears repeating. This is a very, very experimental, nascent capability, and we continue to build on it. But we still, until very recently, had this issue of how do we quickly share, debug, and basically just take what was isolated to sort of one single user within their desktop environment. How do we turn that into multiplayer mode? And we've done that through Cesium. So this shows the debug view, but basically, I think one of the most significant quality of life enhancements for our product team has been the ability, which unlike our hardware team, are a little bit more sort of distributed. Not everyone's co-located. This allows folks to quickly share the exact same, to share a specific view, a specific angle, for folks to quickly get on the same page and identify fixes and continue to push the core sort of algorithmic stack forward. These are like the components we have so far. There's additional capabilities that we're rolling out in terms of the performance or the load on the computer, the amount of the spacing, the point size, that sort of thing. I won't play this full video since I'm a bit short on time, but this gives you a view of how everything comes together. And at some point here, yeah. So at this point, I toggle layers, and then yeah. So we can effectively bring every single Site3D collection we've had into this tool, load them on the fly. Whereas in the past, we would have had to. It would have taken 20 minutes and would have fried this computer that I have. to be able to sort of quickly toggle between different data sets. So that was a lot, but I don't know that I have much time for questions, but thank you, everybody. Thanks for your attention.